Hello everyone, welcome to the experiment 4 of the Introduction to Microcomputer Lab. In this lab, we're going to explore the logical operation of the ARM Cortex-M architecture with simple solutions. The logic operations we're going to discuss in this experiment is the one that you are actually seeing in the screen. Before moving into the logic operations, I'm going to explain one of the command that has been actually repeatedly used in the coding, which is DCD. DCD typically stands for Define Constant Double Word. It is an assembler directive used to reserve storage space for one or more 32 DCD bits, words, or double words, and initialize them specified constant values. So the logic operations that we're going to discuss in today's experiment is AND operator, OR operator, bit clear operator. AND operator performs bitwise AND operations, as we can understand, and register and store the values in the register. Here RD and RN are the register has been symbolized as a register, but in the real experiment you're going to see the value has been registered in the register like R0, R1, R3, R4. And ORR operation is the OR operations. They're going to do the bitwise OR operations. And there is another operation called BIC, bitwise clear. Clear the bits in the RD register that's set as a value of the register of the RN. BIC RD RN clears the bits in RD and that are set in the immediate value. And then now we can use 3 operands for the BIC operator and clears the bits of the RD that are set in the value of the RM. ORN operator, bitwise or not. And this is also been operated by 2 operands and 3 operands. And there is another one which is called EOR, bitwise exclusive OR. XOR, which you can call it. It also has 2 operands, 3 operands, and then there is ASR, arithmetic shift right. Shifts the value in the register Rn arithmetically to the right by the specified immediate amount. The result is stored in the RD, and then ASR RD Rn shifts the value in the register Rn arithmetically to right the number of the bits specified in the register RD. And then LSL, logical shift left, and then LSR, logical shift right. So these are the operands, logic operations. Those are actually used for logic operators as a logic operators and can be used for 2 operands, 3 operands. And there is another operation called ROR and RRX. ROR is the rotate right, and RRX is the rotate right with extend, means the rotates the value in the register to the right by 1 bit, with the carry flag C being included in the rotation. The result is stored in the RD. So today's procedure is pretty much simple. We're going to experiment the experiment 3's last code. We're going to use this template for the logic operations experimentations. First, we're going to create a new project as Lab4, and then we're going to include the startup file that has been actually included in the module 4 also, eventually been included in the previous module in the experiment 3 too. And then you're going to take a new assembly file, and then you're going to take the template of the experiment 3 directly, and then you're going to see the modifications in the upcoming slides to explore the logic operations. The first we're going to see, we're going to use you can see the DCD operations. As you can see, the DCD operations has been, DCD operator has been actually used to allocate 32 bits in the RAM. And then you're going to first see how the 32 bits has been actually allocated into the data allocation directive. And then you're going to answer all the questions and observe the memory registers and memory windows and memory and the disassembly windows observations. You're going to write down everything with your observations and screenshots too. And then the B is to go to the simulation window and with the different value of x. You're going to put different value of x, 0x 100, 0x 10, and you're going to see the register value and the memory address value. You're going to see with also the observations of the experiment and also the screenshots to make the lab report. And in procedure 5, you're going to see the value of the x value will be changed, and then you're going to answer the question. And then we're going to answer the question of what changes has been done in your code if x is a signed number. You're going to explain in your lab report too. So in A, you're going to write down the following expressions: z, which is equal to x less than 12, and y and 250. So you're going to use DCT operator again to allocate 32 bits in the RAM for XY and save the result in the Z in the memory location. The memory location here might not be the same one that you're going to encounter in your experiment. So you're going to write down the Z memory location here. First, the step is actually explaining here. I'm going to explain the steps for this particular A sub-step. The steps are actually, first you're going to allocate the 32 bits in the RAM for X and Y using the data allocation directive DCD. Then you're going to find out the X value that is been stored in the memory address and the Y value, and also the value that has been stored in the R0 and R1. And then you're going to use the logic operation LSL, shift the X value to left by 12 and using AND. Then perform an operation, AND operation with Y value and 250 with the results LSL and AND operation, which are each stored in R4 and R5 register. Then perform an OR operation between the two using OR operation. The result is stored in the memory address. So you're going to write down the memory address observations. And then the B. In B, you're going to see the simulation for different value of the X. You're going to follow the similar steps like you've done in the A, and then you're going to write down all the memory address and the value of X and Y and answer the questions. And the C is if the calculation is performed with the X value of 4096, the Y value 89, which are the same as this, the result will be this, which is correct. So it is stored in the memory address. What memory address it will going to be stored, you're going to find out. And then we're going to follow the procedure 6. Procedure 6 has 3 sub-steps: A, B, and C. A, B, C, and D. So first you're going to set the value of bit 6 and 1 of X and store the result into the same memory location, and then set the bits of 6 and 1 to the X value by using the logic operation ORR with the mass value of 42. The mass value was obtained by setting only bits how much you're going to observe that things. And then B is to use the clear operands, as you can mention, that the clear operand is going to use to clear the 4 and 2 of X using AND operation, and you're going to reset the bits of 4 and 2, and then you're going to perform the AND operation, store the result in the same memory location. And the same is going to be done in the C, but in this case we're going to use the BIC operation, bitwise clear. Here you can see the BIC is bit clear operations. So that bit clear operation will be used here, and then you're going to toggle the bits of 7 and 5, 3 and X and store the result in the same memory location. And also you're going to observe the memory window and the register values along with the screenshots. Thank you very much. If there is any kind of question, you can ask.